Good day, ladies and gentlemen. This is Sarah van Gillen, aka Mr. VG, and whoa, it is exciting to be on video 3 already in this series about grade 11, paper 1. And we are just now in this section of the paper looking at equations. Remember, I'm working through the Department of Basic Education, the 2020 final exam paper. And I'm now still on question 1, which is about equations. But now we kind of shift towards some more applications of equations. We are now going to look in this specific video about some nature of the roots. We are going to look at simultaneous equations. And then we are also going to look at just actually an application to graphs. So let's start by asking you to go and do this one yourself. So go and hit the pause button, try this one yourself, and then you come back and then you work through what I am going to show you. When we look at question 1.3, I'm basically going to go down a rabbit hole. Okay, I love to do this because I don't necessarily always think what is being asked. I like to think about what could they ask. So if I look at question 1.3, they are saying, given that f of x is equal to x squared plus 8x plus 16, first of all, it is a parabola. Okay, look where my mind goes. I don't just look at an equation, I look at where can it go. So looking at a parabola, it is smiling because of the 1x squared, and it has a c value of 16. Easy. I love to analyze my questions. Then 1.3.1 is asking me for f of 2. Remember, that means replace x with 2. That's our methodology. What does it mean? What does that 36 means? It's actually a set of coordinates on the graph. Look where I'm going. So that when we get to question 1.3.2, where it says, determine the values of x for which f of x is greater than 0, I'm putting x squared plus x plus 16 greater than 0. Now I need to solve it. It is a quadratic inequality, which means that I've got x plus 4 and x plus 4 greater than 0, which is x plus 4 squared greater than 0. I'm going to stop there for a moment, and I'm going to think about where are we going? It is asking me which values of x will that expression be greater than 0. Now the only way, not the only way, but the way that I love to do it is to look at what kind of a graph is this. I love to use visual. This is a parabola, which means my graph looks like that. And the question is, where are the y values greater than 0? Now I put that extra coordinate, the 2,36 on there, because maybe I need to use it. So again, looking at the y values greater than 0 or the y value smaller than 0, and I'm looking for greater than 0. So I'm first of all going to look at that leg there and the other leg. So I'm looking at both legs, except where x is equal to -4, because I don't want equal to 0. In other words, x can be any number, but not -4. I hope it makes sense. I hope it makes sense. Why does it make sense algebraically? Because remember, if I look at a square, any square number, except for non-real numbers. We're not looking at non-reals, we're just looking at real numbers. Any square is bigger or equal to 0. That is what we know. Because if I take a number, I square it, the answer is non-negative. The only time when it is equal to 0 is if my expression is equal to 0. So in other words, if we look at this, we are saying x plus 4 squared is always larger or equal to 0. But I want to exclude the equal to 0. So I want to exclude that because I don't want equal to 0. So therefore, I'm sitting with that answer. X can be any number except -4. I know you might have done it easier or different. Oh man, I would love to see it. I would love to see it. Let's have a look at the next question. Now this is solving for x and y in a very weird two expressions. The one on the left-hand side is a linear expression. The one on the right-hand side, I have zero idea what kind of a graph is that. But because they're saying x and y, I'm going to use simultaneous equations. In other words, I'm going to first of all get y alone, follow through my basic steps, substitute that answer into my second equation, which means replacing every y with 2x minus 1, because remember y is equal to 2x minus 1. If I remove my brackets, I can see that this is now a quadratic equation. With quadratic equations, as you hopefully know, but let me go through it, I need equal to 0. So I'm going to take all my expressions and put it on the left-hand side, which means x squared minus x plus 12 is equal to 0. Again, I want equal to 0. Why? Because it's a quadratic equation. This will lead me towards two solutions for x being 6 or 2. But remember, the question was solve for x and y. So if I look at solving for y now, remember that I have that y is equal to 2x minus 1. So I'm individually substituting those y values in, and I am finding two answers. This means that I have two sets of coordinates, 6, 11 and 2, 3. This means, ladies and gents, that you have the solutions where two graphs are equal to each other. That is a very, very important thing for you to understand. That's why we do simultaneous equations. It's where two graphs intersect one another. So when we look at the last one, which is another application of graphs, or of equations actually, is determining whether roots are real or non-real, etc., etc., etc. So let me give you my 2 cents worth on how to solve an equation like this. It says here, for any real value of p, prove that the roots, okay, so I read the word roots, okay? So I'm first of all just going to multiply out my brackets so that I see what am I actually working with. I'm working with a quadratic equation. So if I work with a quadratic equation and I read the word roots, I must think about solutions. Well, that's not just with quadratic equations, but that's with any equations. When you read the word roots, think of solutions. So I've got two options, okay? I can either try and solve the equation, or I could use because it is quadratic, and please again, only because it is quadratic, I can look at getting it equal to naught to work with the discriminant. Only works with quadratic. If they say anything else about roots and it's not quadratic, we have to look at solving it. Solving, because roots mean solutions. For me to go towards delta, I first need to get equal to naught. I'm not even looking where I'm going at the moment. I'm just solving, finding an expression for delta. I'll worry about where I'm going later on. So I need to get equal to naught. So I am putting all my expressions on the left-hand side. I'm still not happy because it's not standard form. So I am going to take out an x squared common. And now it's standard form because I wanted ax squared plus bx plus c equal to 0. This means that a is p squared plus 2, b is negative 2p, and c is 3. So delta, which is b squared minus 4ac, if I substitute this in, b is negative 2p, a is p squared plus 2, and c is 3. Multiplying it out, I'm just trying to get an expression going here, which means that delta is negative 8p squared minus 24. I haven't even looked at the question. I'm being honest with you. At this moment, I haven't looked at it. Now I need to know, where am I going with this? Okay? Remember, this is still delta equal. It's not 0. It's not something else. It's delta. What are they actually asking me for? Prove that the roots are non-real. In other words, I need to prove that delta is smaller than naught. No matter what real value for p I insert in there. So let's start. Where do I start? And here's a tip. Whenever I want to prove roots real, non-real, I'm always start with the square, because p squared is always greater or equal to naught, or non-negative. Once I've got that, I'm going to start manipulating it. So I'm trying to change the left-hand side into delta. That's basically what I'm doing. So I'm going to multiply straight through by negative 8. But I can't just multiply by a negative number. I've got to swap the inequality. In other words, we are now sitting with negative 8p squared being smaller or equal to 0. I am still not happy because the left-hand side is still not delta. Remember, I'm trying to get it into that expression. So if I subtract 24 on both sides, then it cannot be equal to naught anymore. It must now be smaller than naught, because remember, I subtracted 24 from the right as well. So in other words, what am I sitting with? The left-hand side is delta. The left-hand side is delta. So in other words, delta is smaller than naught. Therefore, the roots are non-real. As simple and as straightforward as that. So when you look at a sum like this, ladies and gents, and they're talking about roots, remember they're talking about solutions. Then you have to look, what kind of a sum am I looking for? Is it a quadratic? If it is a quadratic, I can work with discriminant and everything I know about discriminants. But if it is not quadratic, I can't use delta. So then I've got to look at solving it. Maybe graphically, maybe using other forms of mathematics to get a solution or look at the types of solutions that we are specifically asking you for. So please be careful, grade 11s, that the moment you hear root, you don't just go to delta. And I've seen this happen so many times, that students just go towards delta and they think, oh, this is just the way that it is. No, it's not always delta. It's only with quadratics and only in situations like this where we are looking at real, non-real, those kind of solutions. Ladies and gents, this is Mr. VG signing out. Please tune in for our next video where we're going on to question 2 on this question paper. And you'll see what it is when you tune into our next video. So keep well. Cheers.